99% of the atmosphere, the nitrogen and the oxygen in the atmosphere does not absorb infrared radiation. It's really down to the small change in the atmosphere. The biggest absorber is water vapor. But there's a problem with that, and we already know what it is. Warmer air holds more water vapor. If the Earth gets warmer, you get more water vapor and you get more warming. We can't explain a stable climate with water vapor. Next up is CO2. So at the time Tyndall did his measurements in the atmosphere, 3 out of every 10,000 molecules was a carbon dioxide molecule. Today it's closer to 4. Okay, so it's an extremely small amount of carbon in the atmosphere. And they immediately recognize, okay, it's a small amount, that means we can change that. We can change it, that means that it can change. In the 19th century, they had evidence of glaciations, geologic evidence of glaciations. They knew that the Earth had had different climates. They were also burning coal like crazy. They knew that they were putting carbon into the atmosphere. It was natural for them to be curious. What is the impact of carbon dioxide on climate? And this was worked out by a Swedish chemist named Arrhenius. He was the first climate model. He had a climate model. He had a set of equations to solve, and he solved them on a grid covering the Earth, and he solved them on a computer. He was the computer. He worked it all out by hand. It took him over a year to do it. And he worked out that if you double the carbon dioxide in the atmosphere, it would raise the temperature of the Earth by a few degrees C. Okay? And that's basically what we know now. The basic understanding of what carbon dioxide does to the climate system was basically in place by the year 1900.